Ladies and gentlemen, good afternoon once again. This is the penultimate session of our series of lectures. I hope you'll be very happy because we have one more lecture to complete. Today, we are in session 12. We are going to discuss how we organize and graph qualitative data. Please go back to the session where I discussed qualitative variables to refresh your memories, maybe before listening to this. It will help you greatly. Now, we begin this session with a discussion on how to organize and display qualitative, that is, categorical data with one variable. Before then, let me explain what categorical data means. Now, categorical data simply indicate the total number of objects, individuals, or events a researcher finds in a particular category. This is why I said it would serve you better if you went back to your lesson on categorical variables. But let me continue. Thus, a researcher who reports the number of people for or against a particular government policy, or the number of students completing a program in successive years, is reporting categorical data. Take note that what the researcher is looking for is the frequency of certain characteristics, objects, individuals, or events. And many times, these frequencies are converted into percentages to make analysis of data simpler and clearer. At this point, it will be helpful if you go back to session 2, where I have talked about categorical variables. These are your objectives. And these are what we are going to concern ourselves with. 1, organizing one variable, that is univariate data. And then 2, graphical representation of qualitative data. Your references as usual. All right, topic 1, organizing one variable, univariate qualitative data. Now, we have talked about what qualitative data stands for, so I'm not going to go into details again. Let me just go ahead to see how we organize qualitative data. A data set is organized and displayed by constructing tables and by making graphs. That is, if we have data, we can arrange the data first in tables and then construct graphs to represent the data in the table. And a preliminary step towards making data more manageable is that the data may be arranged in a frequency distribution, that is, a table of each possible score, ordered according to magnitude and the actual frequency of occurrence. Let us look at the following example. A sample was taken of 25 senior high school final year students who were planning to enter university. Each student was asked which of the following majors he or she intended to choose. These are business, economics, management information systems, behavioral sciences, and other. Now, what you see there are the responses. Now, your issue here is to construct a frequency distribution table for these data. How do you do that? The frequency distribution table is what you have seen. You see on your left-hand side the courses which each individual will want to major in: business, economics, MIS, other. Now, in the middle part, you have the tally. After every 4 strokes, you cross with a bar, the fifth one. So for business, we have 5 plus 1, making 6. It follows with economics, 3, and then MIS, 3, and then the other 8. And then we have, I think, business management, 2. Now, when you have finished with that, it is important that you convert the absolute score or the scores into percentages by using this formula. That is, relative frequency of category will be given by the frequency of that category divided by the sum of all categories. And then also the percentage frequency, which is given by the relative frequency multiplied by 100. What I have just said is illustrated on the table. You see the measures on your left, and then the relative frequencies in the middle, and then the percentages on your right. Now, based on the above data, we can state that 24% of the students in the sample intended to major in business. We can add the percentage for the first two categories and state that 36% of the students intended to major in business and economics. Now, you have to take note of certain characteristics of tables. Now, the variable or the subclassification within the attribute studied is placed on the left side of the table, while the number of cases, that is the frequencies, is placed or are placed on the right-hand side of the tables. Secondly, the column of the table which lists the attributes or the variables and the column which lists the frequencies are appropriately labeled. Thirdly, the frequencies are added up, and then the tables have titles. Now, a table is simply a two-dimensional representation of statistical information, as we have already seen. Now, let's go to topic 2, graphical representation of qualitative data. What we have done can be represented graphically. So let us see a few examples of these graphical representation we are talking about. So a graphic display can reveal at a glance the main characteristics of a data set. Now, instead of having the tables, if you have the graph, you can see at a glance the whole picture. The bar graph and the pie chart are two types of graphs used to display qualitative data. I hope you have an idea about these already. If not, let's see what they are. So, bar graph, and we are going to look at a simple bar graph. This is a graph made of bars whose heights represent the frequencies of the respective categories. So you see that the bars are not just there, but the height of every bar is associated or related to the frequencies we saw on the table. Now, to construct a bar graph, we mark the various categories on the horizontal axis. All categories are represented by bars of equal width. Now, we mark the frequencies on the vertical axis. Can you distinguish between the horizontal and the vertical axis? We have talked about this some time ago, so you should be able to identify them. But if you can't, let's go ahead. You see what they are again. Then you draw one bar for each category such that the height of the bar represents the frequency of the corresponding category. We leave small gaps of equal length between adjacent bars. This is an illustration. Go back to the data and you see what they represent. Do you see the data? Now, having looked at bar charts, let us look at pie charts. We have looked at bar graphs. Let us look at pie charts. If you don't want the previous representation, this is an alternative. This is a circle divided into portions that also represent the relative frequencies or percentages of a population or a sample belonging to different categories. So a pie chart is mostly used to display percentages. How do you calculate the sizes of a pie chart? That is what you see. You see the relative frequencies, and then on the extreme right, if you want to convert this into percentages, you multiply that by 100. When you have got this, there's a way and means by which you divide the circle, that is the pie chart, into their responding frequencies. So you are able to demarcate the percentage occupied by the frequencies by simply using a protractor. If you know how to use the protractor, it will facilitate the division of the pie chart into the various percentages as we have identified. So for business, you have 24%, economics 12%, MIS 24%, business 88%, and then others 32%. You must know how to use the protractor to divide the circle to represent the various courses students want to offer. That is by this example. We move on to another step. We are now going to learn how to graph bivariate qualitative data. We often may have information on more than one categorical variable for each element. Such information for two categorical variables can be summarized and presented using a two-way classification table, which is called a contingency table or cross tabulation. Now, for data involving two variables, the bar graphs can still be drawn, but a combination of different types of shading as well as blanks can be used to distinguish the variables. Let's take a look at an example. The following data represents the responses of two questions asked in a survey of 40 students majoring in business. What is your gender? This is a categorical variable, you remember. Male or female. And what is your major? Accountancy or computer information systems or marketing. This is also a categorical variable. So we have two categorical variables here. Gender, male, female, and then major, accountancy, computer information systems, and marketing. So this is the distribution. Gender, you have male, 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 female, male across, and then the course they like to read are also labeled across. And then the second one, and then again. So you know that in this example, gender and subject major are two variables being considered. Now, so this is how the tally becomes. We tally for the distribution of students' major by gender. We tally for the distribution of students' major by gender. So on your left-hand side of the table, we have the major, accountancy, computer information system, and then marketing. And then on your right-hand side, you have male and female. So you can see clearly the number. You can count the number of males who want to read a particular course as against the number of female who also prefer, other courses. So now we reduce our tallies into absolute figures. So for majors, we have accountancy, 12 for males, computer information systems, 9 for males, 6 for females, marketing, 4 for males, and then 2 for females. Now, totaling 40. The first one, accountancy, male, female, total 19. The second, computer information system, total 9, 6, 15. The third, 4 and 2, making 6. The overall total is 40. That is, the sample is 40. So then, how do we represent this information? We do that by using what we call the multiple bar charts. Now, this is a useful way to visually display bivariate categorical data when we are looking for patterns or relationship. Now, a multiple bar chart is similar to a simple bar chart. The only difference is that in the multiple bar charts, 2 or more charts or more bars, each for a category of a second variable, are constructed close together for each category of the first variable. Now, this is illustrated better with an example. So the following chart is a multiple bar chart which uses the data from the students' majors as examples. So you see, you have accountancy, you have the bar for males, and then bar for females. Computer information, you have bars for males and females. And then marketing, you have also bars for males and female. The red is represented by male, and the green represented by female. So this is a multiple bar chart of gender based on students' majors. So graphical representation of quality, we are still on. Now, another useful way to visually display bivariate categorical data is by constructing a component bar chart. A component bar chart. 2 types of bars which have been constructed for the student majors, major data as below. You see that this is different from the first one. Here, one is resting on top of the other, but you know, the colors represent the various percentages in the various subject categories. Ladies and gentlemen, yet we have come to the end of another lecture. I hope you understood this, even though we rushed through. It is important that you go back, sit down, and take time and go through the lecture notes. For this one in particular, go through the lecture notes systematically. If you are able to do that, you will understand all that we have discussed today. Attempt some of the questions I have asked and discuss them with your colleagues. I wish you well. We shall meet again. Thank you.